Here are the parametric equations of our plane curve in number 17. The slope is dy d theta over dx d theta, which equals this quotient, which simplifies to negative 2 sine cubed of theta cosine of theta. So writing the equation of three tangent lines, we'll use point slope form, where the slope goes here, and the point the line goes through has x coordinate and a y coordinate, which go here and here respectively. Here's the first point where they ask us to find the tangent line at. So the equation will look like this. And then all we need is the slope and we're done. Second point is 0, 2. So from x we'll subtract 0 and from y we'll subtract 2. What's the slope? And for the third point, x is 2 root 3 and y is a half. So again, what's the slope? Well, we can find the slope and be done with this problem by filling in these boxes. If only we knew the theta value at each of these points. So that's our next step. Let's find theta so that we can substitute it in and get our slope. And then we'll have our three equations of tangent lines at these 3 points. All right, how to find theta? Well, this one's real easy. Let's draw a quick thumbnail sketch at that point. 0, 2 has a rotation of pi over 2. So when we plug in a pi over 2, the slope is all of this times cosine of pi over 2, which is 0. So the whole thing is 0. All right, so the right side is 0, so y minus 2 equals 0, or the horizontal line, this is the tangent line when the point is 0, 2 for this plane curve. We're done with that one. All right, now let's do the more difficult ones. Let's find theta so we can find the slope and be done with this equation in point slope form. Well, if we set this x expression equal to negative 2 over root 3, we'll find out that theta is 2 pi over 3. Watch. 2 cotangent of theta is negative 2 over root 3, dividing both sides by 2, rationalizing the right side. And this is a benchmark trig ratio. Theta is 2 pi over 3. If you don't feel confident identifying this as a benchmark trig ratio, then come see me before or after class sometime and we'll practice it a little bit. So back to finishing this tangent line, we need the slope. Now that we know theta, we can substitute it into this expression and find the slope. Sine of 2 pi over 3 is root 3 over 2. So when you cube that and multiply by cosine of 2 pi over 3, which is negative a half, times negative 2, it all simplifies to 3 root 3 over 8. All right, now down to this one. Oh, before we go down there though, notice that if we had set the y expression equal to 3 halves, we would have ended up with the same theta value of 2 pi over 3. Observe. Dividing both sides by 2, taking the square root of both sides, and what do you know? When you're over here in quadrant 2, by moving to the left and up, the sine ratio being root 3 over 2 is when theta is 2 pi over 3. All right, so we can do that to find the theta measure for this third point's tangent line. To find the slope, we need theta. And to find theta, we can use that the x-coordinate is 2 root 3 and or the y-coordinate is 1/2. Doesn't matter which you use. You might do both just to confirm that you didn't make a mistake. When we solve for theta, we should get pi over 6 in both cases, and then we'll know what the slope is and we'll be done. Cotangent theta is root 3, so theta is pi over 6. If that's not clear to you, maybe do the reciprocal of both sides. Tangent of theta is 1 over root 3. And again, that's a benchmark tangent ratio. Again, theta is pi over 6. If you had done it with the y equations, setting the y expression equal to the y coordinate, then we have sine squared of theta equals a quarter, and if sine squared of theta is a quarter, then when you take the square root of both sides, sine of theta is the square root of a quarter, which is a half. And that happens when, and again, think about where this is in the plane. We're going to the right and up, so it's quadrant 1. And so the sine theta is 1/2 in quadrant 1 when theta is pi over 6. So it works, both of these yield theta is pi over 6. And so to find the equation of this tangent line, we enter pi over 6 in for theta. We have -2 times a half cubed, so -2 times an eighth, or -a quarter. And cosine of pi over 6 is root 3 over 2, so -a quarter times root 3 over 2 is -root 3 over 8. And that is where I would stop.